All right, a little bit of vector in our life. How about that? All right, so really what we're going to be doing, right in front of me. All right. 1, 2, 3, 4. And this is our third to last lesson. We're coming to the end. All right, so as we do vector, these are going to be just like parametric from last time where I have like an x equation and a y equation, but we're going to put an overlay of some physics on it, essentially. So I have a specific way of writing vectors. I don't know what, do you guys do vectors in physics? Yeah. All right, do you guys use I and J or do you use like angle? All right, we're not going to do that because I don't like I and J. I like to write them kind of like points, but instead of parentheses, we're going to use what's called angle brackets. They look like this. So we're going to have x of t, comma, y of t. Both notations are fine. So if you're a big I and J fan, you do you. But I like this better because it looks like a point. With all of your hope and your wishes, do you guys need another one? Did I miss you? I'm just not doing that. No, I've missed something. All right. With all of your hope and your dreams, what do you hope will happen to get the velocity vector? The derivative, and just do the derivative of each one. Wow, you're brilliant. Nice part. Parametric kind of does what you want it to do. What would you hope the acceleration vector looks like? X double prime, Y double prime. Nothing crazy. So we're just splitting essentially the horizontal and vertical motion. So let's see what this looks like, and then we're going to talk about magnitude. So we've got a particle moving in the XY plane. We've got the position of that particle, and it's given by these two equations here, both in terms of t. Here we're really feeling that t equals time kind of vibe. So we're going to find the velocity vector when t equals 1. So the first thing I'm going to do is I'm going to find v of t. Uh-oh. Nope, we're still good. By taking a derivative. Anyone feeling real brave about the derivative of t cubed plus 4t? Uh-huh. Wow. All right. Someone who's just as brilliant as Brandon. Does anyone feel like doing t to the 4th minus t cubed? All right. With all of our hopes and dreams, we're going to find v of 1 by, you guessed it, plugging in 1. So that would be 3 plus 8 is 11, and 4 minus 3 is 1. Now, some things we learned from getting this 11, comma 1, essentially that 11 means we're moving relatively real fast in the horizontal direction to the right or whatever the positive direction is. That 1, we're moving kind of slowly up. So we're doing something like that. Cool. All right, do you guys think you can find the acceleration vector when t equals 2? I bet you can. I'm going to give you a couple minutes. Yeah, imagine if we ended the year with Taylor series. Yeah, A of t is what I would call it. I like to come back to this and then torture you with polar. I'm going to simplify polar this year. I feel like I teach some extra stuff in that. There's everyone. The halls get crazy near break. $48. I always say if you learn enough math, something has to leave. So like addition and multiplication. Yeah. Let's see, that's 20. You said 36. Can I cheat off of you? 48 minus 12. No, I like that. I like that. Oh, that's a terrible angle bracket. All right, so you should be getting something like 20, 36. All right. Yeah, Jane. I got 48 minus 12, which I think is 36. Got it? All right. Now, magnitude. Vectors are actually kind of like little arrows, if you will. So a vector has our x and y components, but sometimes we might want to know the magnitude of that vector, aka kind of the distance on that vector. So let me draw you a couple of pictures. You're going to get a little bored of this in a second because it's going to be the same thing every time. But what we're doing with this vector, this little arrow guy here, is we're splitting it up into our x direction and our y direction. So let's say we wanted to know kind of the distance along that arrow right there. What old dead Greek man can we ask to help us? Pythagoras. So I would argue that this side would be the square root, because it would be squared, c squared, of x of t squared plus y of t squared. Would you agree? Because x of t squared plus y of t squared will be question mark squared, square root. Now, that one's not that interesting. The magnitude of the position vector is kind of a weird thing to ask for. We have often asked for the magnitude of velocity. What did we call the magnitude, aka the velocity without like a positive or negative? That had a name. That's like distance versus displacement. Think of like what's the absolute value of velocity? We're talking speed. So if we look at this guy, this is one we'll definitely be asked about. We could split our speed or our velocity into our x and y components of our velocity. So our speed is going to be the square root of both of those things squared. I'll give you notes in a second. Gotcha. All right. I wish mine would be the other way around. At least I like there was a positive. I think I need to plan more time in to teach you. It's probably my fault. Good. All right, what do you think the acceleration, the magnitude of the acceleration vector is going to look like if you were to predict? Yeah. All right, so relatively similar vibes all around. I will say if I'm going to ask you about one of them, you betcha that it's going to be that speed one because that actually has a context. All right, so let's go through and we're going to kind of do all of the stuff that normally gets asked about vector. Really, this is vector parametric kind of put together. Again, we're just overlaying some physics onto it. All right. So we got a particle. Notice that this is a little different than some of the particle questions we've done in the past. If you're an AB, usually a particle that's moving along like the x-axis, so we only have one equation in terms of x. Your particles get to be a little bit more exciting. They get to move along the xy plane, and that's because we have an x equation and a y equation. How thrilling. Really, the hardest part of these questions is just making sure you answer all of the things in the question. So we are going to make sure we do that. So we have particles moving in the xy plane. We've got his position with that x and y equation. We want to find the magnitude of the velocity vector when t equals 3. Could you give me a synonym for the magnitude of the velocity vector? I'm a little out of practice. Speed. So what I'm going to do, since our speed was just our x prime and our y prime squared and added, I'm going to start by finding x prime and y prime. How about I'll do x prime and you guys can do y prime? Sound fair? If you looked at the functions, you might. All right. X prime. I think that's 2t plus 5. Because I planned it that way. All right. And I'm going to plug in 3. That's 11. Can you guys find y prime? Actually, let's just do it together. Y prime. Who knows how to take derivatives of natural log? All right. Whatever's inside goes on the bottom. What's going to go on the top? I don't want to put a 1 there. All right. We're going to chain rule. So the derivative of the inside. So my favorite thing to say, 2t. What? Why is it? You try it. Say 2t. It's just fun. Everyone gets really mad at me. Man, someone in my other class, I called problem cute, and they got real mad. But by the time we got to the end of the problem, he agreed with me. All right, I'm gonna plug in 3. I'm gonna get 6 over 13. Sounds good to me. Yeah. So this doesn't have to be nice. Also, speed, for some reason, speed doesn't have like a letter that goes with it. Physics folk. Do you have a letter for speed? But that's not what speed is. All right, whatever. S is arc length, though. So all of the rubrics in the AP test kind of just label it with the word speed. So that's what I'm gonna do. If that makes you mad, okay. So I'm going to do 11 squared plus 6 over 13 squared. Since that's the last thing it's asking me to do, no way in heck I am simplifying that number. It's a number. All right, did I answer parts of the question? Yeah, I think so. All right, let's go back and let's review some of our favorite stuff. Distance versus displacement. We're not really going to work with displacement here. We're going to more so work with distance traveled because our guy's going to go around. So this is like total distance. Does anyone remember how we found total distance back when we were just moving along the x-axis? All right, we integrated like an absolute value of velocity. I would argue the absolute value of velocity is speed, though, right? So really, I want to integrate speed. So let's integrate speed. We're going to integrate the square root of x prime of t squared plus y prime of t squared dt. Now, if you're really remembering last class when we learned, this was something we learned already. I'm going to go back just to prove it because your eyes tell me you don't believe me. Remember this guy? All right, what was that equal to? Yeah, we called it arc length, right? That makes so much sense in my brain for distance traveled because think our dude, our particle is like moving along an XY plane. And if we found his arc length, aka the length of that curve, that would be the distance he traveled, right? So those two are exactly the same thing. Arc length, overlay on it, the total distance we travel. I made a dog? I mean, ignore the bottom. All right, let's talk about this particle. Let's do some trig because I know that's what you guys want to do on the Thursday before break. All right, we got a particle. He's moving in the XY plane. There's his X, there's his Y. We know we're between 0 and 2 pi. We want to know the path of the particle. What? Okay. The path of the particle intersects the x-axis twice. We're going to set up but not evaluate an expression that represents our distance traveled between those two x-intercepts. All right, so we've got a couple of ideas of what we would like to do. Anyone want to do a thing first? All right, they're talking a lot about these x-intercepts. Do they tell me where they are? Yeah, let's find the x-intercepts. So when something hits the x-axis, the y is 0, right? So let's set y equal to 0. All right, I'm going to add the 2 sine of t over, and I'm going to divide 2. All right, here is the challenge. There are 2 angles on the unit circle where sine of t equals 1/2. What are they? No. All right, it's either 3 or 6. Let's figure it out. All right. I would agree with those saying that pi over 6 is one of them. All right, this is the short side. So that's the 1/2 versus the square root of 3 over 2. In what other quadrant is sine positive? The second one? Because all students take calculus. What is this angle? 5 pi over 6. Nice. So those are going to be my bounds. Pi over 6 to 5 pi over 6. All right. I need x prime and y prime. Please help me. What is the derivative of square root of 3 minus 4 sine t? All right. Is the square root of 3 going to do anything to the derivative? No. So what's the derivative of just cosine then? Negative sine. So I think this is going to be positive 4 cosine t. Oh, sine. What am I doing? Positive 4 sine t. Yes. Okay. Thoughts on 1 minus 2 sine t? Negative 2 cosine t. Absolutely. No. There's a calculator and non-calculator question, but the nice part is if this were on the non-calculator, these are probably the directions you would see, because none of these integrals are going to work very well, so you're usually going to set up but not evaluate them. Because your derivative of a number is 0.
I made it through the AP exam without crying, and I had no idea what I was doing.
There you
I'm
go.
proud of that.
Good. All right, let's do, what time is it? All right, let's do this one last question, and then we'll pick up the last question next time. Let's say we're at rest. Tell me what you know. All right, easier than speed equals 0. Let's say velocity equals 0, right? Because I don't really want to set that whole square root thing equal to 0. But I have 2 components to velocity now. So I want v of t to equal 0, but my v of t is an x component and a y component. If I'm at rest, should both of those components be 0? Yes. All right, so let's try. We're going to find x prime of t. That's 6t squared minus 30t plus 36. I would like to set this equal to 0. Thoughts on how to solve that? Ew. Yeah, let's factor. Is there a GCF? Yeah. How do you think I teach my Algebra 1 students how to factor? You just find the zeros backwards to the factors. That's boring. All right. How do I factor this? t minus 2, t minus 3. So I get t equals 2, t equals 3. Now, these may be my answers. They may not be. All we've learned here is that t equals 2 and t equals 3, this particle is not moving in the horizontal direction. Which 6 doesn't equal 0. So we need to also find y prime of t. We got 3t squared minus 6t. Must set that equal to 0. We got a GCF again. Let's go a little bigger. 3t. So I got t minus 2. So I get t equals 0 and t equals 2. There is one singular time that is my answer. What is it? T equals 2, because we're not moving horizontally and we're not moving vertically. All right, we'll pick up the other question when we come back from break.
One more question. Why did we use for velocity and speed?
Because the vector.
That's what it is.
Yeah.
Oh my god.
Getting another spell.
Cool.
We just use
You can, yeah, if you like ion check. All right, before we leave, I have presents for you.
I don't feel like doing practice.
Oh no, he's getting it out.
This is our last problem.
Yeah. All right, I'm gonna create a station up here for some optional. Some are optional, some are not. So, I'll start with the not optional one. Our last problem set, Unit 10. This is.
That's one of the.
No, my presents are almost always calculus. So.
Wow, just heavily stacked with white.
You don't call them that.
All right, so this you actually can, if you would like to work a little over spring break, you can actually do half of it already. If you would like to try the parametric stuff, so that is one thing. Also, I am a big fan of during fourth quarter giving optional things to people who would like to review for the AP test. So you're going to notice there are going to be some optional experiences that will help you prepare for the AP test, but also if you're interested, help pad out your fourth quarter grade. For your those of you that are seniors, your fourth quarter is really short. There's not a lot of assignments in it. So if that's why you're going to do this, that's also another option. This is a really good opportunity, though, to review for the AP test. So what this is, it's kind of two pieces. I didn't staple them together because I was afraid I'd break my stapler. This is the entire 2012 multiple choice off of the AP exam. It's a pretty darn good multiple choice. It is one of the most recent ones that's been like released to the public, so that's why it's so old. They don't really do that anymore. Some things about this, I will say the answers to this one are A through E. Your test will only be A through D, if that matters to you. Also, this one has 17 calculator. Yours will only have 15. So they went from 28 and 17 to 30 and 15. It doesn't really matter. There you go. If you would like to pick one of these up, this pink sheet has some directions for you. This is, again, an optional experience, but it'll be worth a quiz grade, so like 50 points. The answers are on the back here, so you know if you're getting it right. But I need work and kind of an explanation for all of the questions. Now, you can certainly ask me questions, but this is released, so there's probably help out there on the internet. I wouldn't recommend Googling it and just copying it because that's not helpful at all. But that is an optional experience for you. Can we stop moving for a second? I still have your lives for the next 5 minutes. Can everyone just stop talking? Thank you. So what I would do, I would send up a rep from your table, because I just don't want to. Do you want me to pass all of these out? All right. I'm just feeling real tired right now. All right. Before you start, just stop. Stop everything, please. All right. So the due date for this is a very strict due date, and I want you to tell me why the due date is when it is. The due date is Monday, May 9th at 8 a.m. That is the minute the AP test starts. I do not want this after Monday, May 9th at 8 a.m. because this purpose is to prepare you for the AP test. Now, you're more than welcome to do this if you're not taking the AP test, though I think most of you are. But that's the very last day I want it. I will not take it later because no. Problem sets up here. I don't have a specific due date for this yet, but it will not be the week that we get back. If you're looking forward to the Unit 10 test, fourth quarter, we did a test already. We have it in fourth quarter, done a partner test or a mastery test. So I don't know. Might be an option. All right, that's all I've got for you. So I'm gonna leave this stuff up here. Grab what you'd like. Yep, if you can send a rep from your table, it's easier. Why do I have so many? How are you getting 27 for the expo?
I should have a picture.
I got it 3 times 8.
3 times 8 is the right thing. It's just not 27. Hi. Oh, thank you. So perfect. Thank you so much.
I know it says odd.
And on the back.
Because I have
Yep, absolutely. Oh, thank you.
This one,
What?
So what if, like, May 9th, and you're only able to do like 80% of the program? Is that cool? So I can decrease.
All right, before we leave, there's about a minute left. Make sure if I did not get your yellow problem set for Unit 9, I need it back tomorrow at 4:03, including any corrections, any makeup work. That is the final deadline. Other than that, thank you guys for being you. I will see you after the break for the last 2 lessons here. See you. You look the best.
They're like PDFs of health checks.
There aren't any online, but if you shoot me the ones you need, I can email them to you. Yeah. Yes. Hold on 2 seconds.